All right, we're back in the second semester. We've done some some review work with some of the things that we talked about in the first semester. And so today is sort of our first lesson. The title of the lesson is Lesson 15 from our Eureka Math series, Solution Sets of Two or More Equations or Inequalities, joined by the words and or the word or. We are going to be looking at this word and this word is a big part of our discussion today. But let's start by reviewing lesson 14. Solving inequalities is just like solving equations. Now, again, one of the reasons why we're reviewing lesson 14 is because one of the caveats to 14 was that when you're solving inequalities, of course, some familiar things we're going to distribute through. Hopefully you remember that. And we've spent some time here in the recent days reviewing the distributive property. And you notice that pay attention to the signs. And as I work through this should look very familiar to how we would solve an equation. The work is very much the same. And so we get negative 5x, and we still have the greater than or equal to, and it's 5. And this is where it gets tricky. If we divide or multiply by a negative number in an inequality, that means that this sign right here, I'll change the color, this sign, this arrow here has to change. And so your answer is going to end up being x is less than or equal to, in this case, negative 1. And so that's why we want to review it, just to make sure we remember that particular facet of it. Okay. So from your Eureka Math workbook, lesson 15, you can go to that if you want, and you can fill these in. Exercise 1 wanted you to determine whether each claim given below is true or false. And so what I've done here in the first 4 is I've given you the actual problems, and then I've also given you solutions. We'll talk briefly about why the solutions are what they are. So determine whether each claim is true or false. Right now, I am in math class and English class. Well, we know that to be false because you can't be in both. Okay, because you can't be in both. So the word and here is not possible. B, right now I am in math class or I'm in English class. That's true. So we would say that's true, assuming that you're in this class, in one of the classes. So we bring that to math and some of the inequalities and equations that we work with, and we ask the same question. For instance, in C, 3 plus 5 is equal to 8, and at the same time, is it true that 5 is less than 7 minus 1? Well, the first thing you got to do is you got to go ahead and do the math on this. And so as I do the math on this, I notice that 3 plus 5, well, that is 8, and that does equal 8. So that's true. And what about this? 5. Is that less than 7 minus 1 is 6? And that's true as well. So because both are true, we could say that this is a true statement. D, 10 plus 2 is not equal to 12. 8 minus 3, 5, is greater than 0. Well, even though that's true, this is not true. So because the word is and, both have to be true. Now, E and F, you can pause the video and take a moment on how I did C and D and maybe try that on your own on the sheet that I gave you. So pause the video and try to do E and F. when the two declarations in a sentence above were separated by the word and, what had to be true to make the statement true? Well, as I said, both had to be true in order for it to be true. When the two declarations in the sentence above were separated by the word or, what had to be true to make this statement true? Well, at least one. And I showed that as well. So keep that in mind. It's very important to keep those two facts in mind. Next slide. The word and as you're making these notes, go ahead and underline here, means the same thing in a compound mathematical sentence as it does in an English sentence. The word or also means a similar thing, but not exactly the same, in a compound mathematical sentence as it does in English. However, as it says here in the reading, there is an important distinction, and it's really important that you read and you understand this part right here. The word or is commonly interpreted as the exclusive or one condition or the other is true, but not both. In mathematics, either or both could be true, and it's really important that you understand that. There's a distinction in the word or and how we interpret it in mathematics. So if two clauses are separated by or, one or both of the clauses must be true for the entire compound to be deemed true. So this is a really important concept for this particular lesson. Okay, you're going to be asked to consider scenarios in the real world and create a compound inequality. For instance, look at A. Students are to present a persuasive speech in English class. The guidelines state that the speech must be at least 7 minutes, but not to exceed 12 minutes. So you're going to be asked to select a variable, and I usually select X, and they do that here. And then they're going to write the answer. You see them write the answer in one of two ways. They wrote the answer in this way, two separate inequalities, and then they also wrote an answer that is just as equivalent in this way. With the word and, we can combine and write it like this. X has to be greater than or equal to 7 minutes, and X has to be less than or equal to 12 minutes for the persuasive speech. And then the graph, take a look at the graph, take a look at the distinction, because you're going to be asked to do that as well. Now, the difference is in the next one, it says in the sentence, children and senior citizens receive a discount on tickets at the movie theater. To receive a discount, a person must be between the ages of 2 and 12, including 2 and 12, or, and that's the key word, or 60 years of age or older. And notice, here they have this. So here's your first consideration. Between ages 2 and 12, or greater than or equal to 60. And look at the distinction in the graph. So in the or statements, your graphs are generally going to look like this. And in the and statements, your graphs are generally going to look like this. Okay. If you go to the next slide, we're almost done. Determine if each statement is true. Explain your reasoning. Well, once again, we're going to be doing the math, and we notice that 14 is less than or equal to 14. 1/3 is less than 1/2, so the answer is simply true. So these are pretty straightforward. B, 5 minus 8. Well, that's a -3, and that is less than 0. And then it says or. So only one of these has to be true. 10 plus 13. 10 plus 10 says does not equal 23. Well, even though this one's not accurate, because this one is true, the whole thing can be said as true because we only need one of these. Solve each system and graph the solution on the number line. You're going to be doing that today as well. In D, they solve for this equation, and they solve separately for this equation. So in this one here, you'll notice that we're going to solve individually And I'm going to take this equation down here and show my work. I'm going to add 8 to both sides. And I get 5x is equal to 23 and 8. You can use your calculator if you want. So different signs, we're going to subtract 23 minus 8. Well, 23 minus 10 is 13. That's going to be a negative 15. Divide by 5, and you get x is equal to a negative 3. And I see that there's a mistake right here. That's a mistake. So on the answer key, that is a mistake. And then just to save time, I'm going to add here. And so I'm going to solve up here in the room that I have. And I'm going to subtract 1 on both sides. And I get x is equal to a negative 11. That one they do have correct. They do have correct there. Okay, so they have the negative 3 there, but they didn't graph it correctly, but that's all right. Next page. Okay, so then you're going to be asked to graph the solution in a compound inequality. So they're going to give you something like this, and they're going to ask you to graph each. So x is less than negative 8. You see it going out over here. And x is greater to negative 8. You see it going out here. And they left this open. Notice that. And then f, x is greater than 0. It's not equal to 0. And then it goes all the way to 10, and you see a dot that's filled in. Here it's open, and then there it's filled in. So take a look at how they went from here to the graph, and the same thing from here to the graph. This time you're going the opposite direction. They give you the graph, and they want you to find the inequality. See if this answer makes sense to the graph. And the same thing here, they separated it because you could see when it's separated like this, you know you have an or, and when it's together, you know you're going to have an and. Big difference in the graphs you can see. You notice here there's a separation right here with the E. There's a separation here in H. And let's go to our final slide, I believe. And the final type of problem you're going to get is, for example, in I. A poll shows a candidate is projected to receive 57% of the votes. If the margin for error is plus or minus 3%, that meant from 57 minus 3, which is 54, and then going this direction, add 3 to 60. That's the range at which these percentages will be. And so it wanted you to write a compound inequality for the percentage of votes the candidate can expect to get. And that's how they got this answer. You'll be asked today in practice to do a similar problem. It's really just taking what number they gave you. And in this case, because they said add or subtract 3%, that's where they're getting the 54. And then you add, that's where they're getting the 60. Mercury is one of only 2 elements that are liquid at room temperature. Mercury is non-liquid for the temperature less than negative 38, or rather greater than 673.8. And so the inequality you see is right here. Take a look at this answer on both sides of the or and see if that makes sense. You will be doing problems just like I and J today. So lesson 15, the big statement is really dealing with mathematical sentences. Like in English sentences, a compound sentence separated by and is true if both clauses are true, or is true if at least one of the clauses is true. So this is the key idea for lesson 15, keep in mind. And pause this video, go back and rewatch it if you missed something.